We're going to split this up into 3 lessons. Today we're going to do 3-2A, which is solving a system by substitution. Do you?
Yeah.
Good. Now, here's the thing. You're going to learn 3 ways to solve a system. We already learned graphing. We're going to do substitution today and elimination tomorrow. Now, if I tell you on a quiz coming up on Friday, I say, solve this system by using substitution, and you decide, no, I like elimination better. I mark you wrong, even though you may get the problem right, okay? You have to know how to solve the way I tell you to solve. All right, so here we go. Here's how to solve a system by substitution. Number 1, there's really like 3 steps. Number 1, you need to solve for 1 variable. Okay, you're going to be given 2 lines again, and in one of them, you have to have a variable that's solved for, like y equals something, or x equals something, okay? Just in one of them. Doesn't have to be both. Then the second thing you're going to do is you're going to do substitution. Just like when you are in a game or something and you come out of the game and someone goes in for you. Or like last week when I was sick, I left and a sub came in, right? Okay. So you're going to then plug into the other equation. Plug into the other equation. Okay, you're going to take some stuff out, and you're going to put other stuff in. You're not going to, like, Miss Hubbard and I are not going to be here on the same day teaching this class, okay? I'm leaving, and she's coming in, okay? Oh, wherever, anywhere else. All right, number 3. Then, at the end, you need to find both x and y, okay? At the end, you're going to solve for one of the variables. X will equal something. But then you have to tell me what y is. They're points. They're always points, okay? We're still finding points of intersection, just a different way to find them by using substitution. All right, so here we go. Are you ready? I've got like 4 or 5 examples. Number 1, solve by substitution. I'm not going to write by substitution. We're just going to go ahead and know that today is substitution, and that's how we're going to solve. Here we go. Yeah? You got it? Yep. All right, 4x plus 3y equals 4. And y equals 2x minus 7. Okay, so you could have graphed this. Graphing this would have been tough, especially the first equation, because the y-intercept would not have been a nice number. It would have been really hard. Even if you would have solved for y, it would have been pretty difficult. Yeah, it would. It would be gross. It would be bad. So we don't want to solve this on a graph. We're going to solve this by substitution. Now, step 1's already been done for us. It says to solve for a variable. A variable's been solved for, right here. Y equals 2x minus 7. No, that's right there. So we're going to take 2x minus 7. That's our substitution, okay? We're going to go up to this other equation here, the first equation. We're going to take y, and y is going to go to Disneyland for the day, or to the dentist, or wherever I want to go. And then the sub will go ahead and take the place. But see, the sub can do that because this is y, and this is y. Y equals 2x minus 7 is going in for that one. Don't multiply them together. The 1y comes out. The 2x minus 7 goes in. Okay, so let's write that. 4x plus 3 times 2x minus 7. So instead of y goes out, this one goes in, and this is equal to 4. And the reason why we do that is because now we have an equation with 1 variable in it, and we can solve. Okay, so we spent a lot of time solving these in Chapter 1. You guys should be pretty confident in your solving skills. Are you pretty confident in your solving skills, Peter? Yeah? Okay. Distribute the 3. 4x plus 6x minus 21 equals 4. Okay. Keep going. We get 4x plus 6x is 10x. Let's go ahead and add the 21 to the other side. You okay with combining steps now because you're that good? So you get 25. Divide by 10, and x is 2.5. How would you like that number to show up on your graph? That would be terrible. No, you wouldn't. All right, but that's not it. You're not done.
Then you got to plug the x in.
Yes.
For the little x.
Right. Okay. So now you need to take that x and you need to plug it in to any equation, and I'll tell you what the easiest one is.
You plug it into the 10x.
I would plug it in right here. See, y equals 2 times x minus 7. So let's go y equals 2 times 2.5 minus 7. Good. You did that in your head. That's really good. Negative 2. So the point of intersection would be 2.5, negative 2. Do you remember doing this a little bit? Eighth grade. Good. Okay, number 2. Here we go. Maybe I should be mean to you, Wyatt. All right. 3x. Yeah, that's true. I'm a little mean to you. 3x plus 4y equals 12. But never to you, Peter, because you're always smiling and making my day happy. Oh, not to Peter. 2x plus y equals 10. All right, let's do another one. So, all right, we're going to have to do all the steps this time. Okay? That was funny. Okay, so if you look at this one, our first step for substitution is you have to have like y equals something or x equals something, okay? So if you look up here, you have a 3x, a 4y, a 2x, and a y. What would be the easiest one to solve for? Yeah, the y. The bottom one, the y, right? That one's all by itself. It's like begging for you just to subtract 2x over. It wants you to do that. Yeah. So let's do it. Subtract the 2x over to the other side. Okay? Is everyone okay with that? So we have y equals negative 2x plus 10. And now we're ready to substitute. So we're going to take that y equals negative 2x plus 10. We're going to go to the other equation. And we're going to plug it in for y. All right, I'm going to let you finish the rest of this one. You do it. Yeah, you take over. All right, I'm going to do it now. Here we go.
Andrew, why do you always tell people to show up?
Okay, here we go. This one's a little bit tougher because the answers do not come out so nicely. But we would rather solve it by substitution than graph this one for sure, because we would never be able to find those answers graphically. All right, so let's go ahead and distribute the 4. So I get a negative 8x plus 40 equals 12. Is that where you messed up? If you messed up, maybe it was where you had to distribute, because that's where a lot of people will mess up. So I get negative 5x equals 12 minus 40 is what? Negative 28? Oh. So x is 28 over 5. Did anyone do that on their calculator? What is that? 5.6. Good. Okay, 5.6. Now don't forget, once you solve there, you have to go back and solve for the y value. So go up to where y is solved. Y is negative 2 times x, which is 5.6, plus 10. Okay? And then you end up getting negative 1.2. Yes. And it doesn't matter where you plug it in, because it will work in both equations. It'll give you the same point, because that's what we're trying to find, their point of intersection. And that would be your answer. Now, usually I try and stick to nicer numbers like integers, you know, some decimals. That wasn't that bad. All right, let's try one more of these. And then we have a word problem to try. All right, number 3. Yeah. We're going to practice a little bit of word problems here, too. Negative x plus 3y equals 0. And 3x plus 4y is 26. Okay, so the last two, y was the better choice to solve for. It just kind of lent itself to that because y was by itself already in the first one. Y didn't have a number in front, so it was easy to solve. Here, I think x would be the easiest variable to solve for in that first equation. Let's just add x to the other side, and we get x equals 3y. Okay? And I don't want to deal with fractions. I don't want to solve for y. Let's just stick with that. X equals 3y. And you can use substitution. You can substitute y in, or you can substitute x in. It doesn't matter. So for this one, let's take x, which is 3y, and we're going to substitute it in to there, into the other equation. All right, so we get 3. Instead of x, x is equal to 3y. So I'm going to write 3 times 3y plus 4y equals 26.
No, this is one of those tricky birds, huh?
Yeah, tricky birds. Okay, and then 9y plus 4y is 26. So 13y is 26, which means y is what? Shh. Y is 2. Now be careful here, because the last two that we did, we found the x first, and so it's really easy to like just go to your point and put 2 in first. But 2 is the y. 2 is the y value, so 2 goes in the y spot. And now let's find out what x is. Go to where x has been solved for. X right here, x is 3 times y. So what would x be? No. 6. 2 goes in for y. 3 times 2 is 6. Okay, I'm going to give you one to try all by yourself before we do that word problem that I promised you. Here we go. Try this one. 2x plus 4y equals 12. X plus 4y equals 12, and x plus y equals 2. Okay, you actually did this one last night in your homework. It was number 9, but we solved it by graphing, and we got the answer. And right now we are going to solve by substitution. So I want you to try it all by yourself. I want to see if you can get it. Okay, I'm going to go ahead and think that you probably solved for y on the second one, which is great. You could have solved for x also. Okay. But let's go ahead and subtract x to the other side, and you get negative x plus 2. I'm going to take y equals negative x plus 2, and I'm going to substitute it in. Substitute it in means to take out this y and plug in what this y is. This y is negative x plus 2. Okay. By the way, there is a lot of work required in these problems, so make sure you show that in your homework, okay?
Okay.
All right. So now distribute the 4. And you get minus 4x plus 8 equals 12. 2x minus 4x is negative 2x. Let's subtract the 8 over. So x is negative 2. Now don't stop there. Okay? These problems do take, some time. Because once you get that, then you have to go back and find out what y is. You can plug it anywhere you want, but make it easier on yourself. Plug it into where y is equal. And y, it says y is equal to negative x. So a negative 2 is positive 2 plus 2 gives me 4. How many people got that right before I did? Good. 1, 2, wow. More than half of you guys did. Good job. Okay, and here's the last one of the day. Last one. Halfway? Oh, did you get the x? Good. You got to go back and plug it in and get the y. You'll be set. Good job. Okay. CDs. Anyone buy CDs anymore? No. This is kind of an outdated problem, huh? I remember buying CDs. I remember buying cassette tapes.
I remember buying CDs too. Justin Bieber's.
Yes, Justin Bieber. Me too.
No, Justin Bieber.
Yes, he does.
I remember when I was in CDs at a store cost. Whoa, it's expensive. $15.49 each. Shh. I don't know.
$5 more.
Okay, you can go online and you can get them for $13.99, but you're going to pay each, but then you're going to pay a flat rate of shipping, so not per CD, but a flat rate shipping of $6. Is it? $6. Okay. Here we go. I know. It's my pen. We're going to do 2 things here. Letter A, I'm going to ask you to set up a system of equations to solve. Okay? Do not skip this step. If you do, you're going to not get this problem right. I mean, you might get the answer right, but this is part of it. Okay? You have to set up a system, 2 equations. And then we're going to, part B, we're going to find the cost of CDs that would be the same. The cost that would be the same. Okay? All right, so here we go. We have two instances here. We have, first of all, we have the cost of a CD, we'll call it Y, is equal to $15.49 per CD times X. So we'll say that Y is the cost, the total cost of what we have to pay, and X is going to be the number of CDs. So Y equals 15.49X. That makes sense, right? Okay. The other cost, which we'll call Y, is $13.99 per CD per X. But then what? Plus 6. Very good. Plus 6.
I like that.
Okay? So there's two different, this is situation number 1, this is situation number 2. And now what we're going to do is we're going to solve our system. So that's part A, is to set up. And we're going to practice this a lot on Thursday with word problems. The word problems are tough for people, but I want to get you kind of ready for it. All right, so now they're both equal to Y. So guess what you can do? Take 15.49X and plug it into Y. And this should make sense because we want to find out when this situation equals this situation. Right? We've kind of done this before. We did this with when you rented a car. We did one. We did one with a little kennel, like the dog kennel problem. We had one there too.
Oh, I seen a dog.
Yeah. Okay. Good job. Okay. So now subtract 13.99x. 13.99x. Subtract from both sides. And we get 1.5x equals 6. Divide by 1.5x and x equals 4. Now here we go. Whenever you have these problems, two things. One, you want to go back and see what they were asking for. They asked me, when is the cost the same? If I tell them x equals 4, or find the number of CDs and the cost that was the same. Okay. Yeah, so 4 CDs. And then we have to go back and find how much it costs that they're going to be the same. So you can go back to either one and plug in 4. So if I do Y equals 15.49 and I'm going to buy 4 CDs, it's going to be $61.76.
I did the 13.
Who has money to spend like that? I don't. Okay. Now listen up. Shh. If you decided to go $13.99 times 4 plus the $6, guess what that's going to be? $61.76. So it doesn't matter which one you plug in. It's their point of intersection. It's going to be the same.